Hi, I'm Mr. Parker and this is question 3 on the OCR Core 2 paper from June 2014. The diagram shows a sector OAB of a circle, centre O and radius 12 centimeters. The angle AOB is 2/3 pi radians. So again, all shown in the diagram here. And in part 1 we need to find the exact length of the arc AB. And in part 2 we need to find the exact area of the shaded segment enclosed by the arc AB and the chord AB. So to find the exact length of arc AB, we need to use the formula for arc length, which says that arc length is equal to the radius multiplied by the angle. But remember, in order to use this formula, the angle must be in radians, which it is, so we're okay. So all we need to do to find the arc length S is the radius 12 multiplied by the angle 2/3 pi, and 2/3 of 12 is 8, so we get 8 pi. In part 2 we need to find the exact area of the shaded segment. In order to do that, we're first going to find the area of the sector, which is the whole of this shape, and then we're going to subtract the bit that we don't want, which is this triangle here. So to find the area of the sector, we're going to do A equals a half r squared theta, where theta is in radians. So the area is a half multiplied by 12 squared multiplied by 2/3 pi. 12 squared is 144, half that you get 72, and then 2/3 of 72 is 48, so we get 48 pi. For the triangle, we're going to use the formula that the area of a triangle is a half AB sine C, where A and B are two sides of the triangle, and C is the angle in between those two sides. Well, in this triangle up here, we've got a radius of 12 here, but on the other side we would also have a radius of 12 here as well. So our two sides A and B are 12 and 12, and our angle sine C is 2/3 pi. So we're going to get a half multiplied by 12 multiplied by 12 multiplied by sine of 2/3 pi. If you're confident at converting between radians and degrees, you may have spotted that 2/3 pi is actually 120 degrees and be able to do that calculation in your head. But let's suppose you didn't remember that. Let's look at what we do on our calculator. Because our angle here is in radians, we need to make sure our calculator is also in radians if we're going to do the sine of it. At the moment my calculator is in degrees mode. I can see that by the little D up here. So what I need to do is change the mode of it so that it's in radians. Always look out for a little r when you're doing calculations in radians. So we need to do a half multiplied by 12 multiplied by 12 multiplied by sine 2/3 pi. And that gives us 36√3. Remember, we're finding the exact area, so I don't want a decimal approximation for this. All that's left to do now to find the area of the segment is to start with the area of the sector, which was 48 pi, and subtract the area of the triangle, which was 36√3. There's nothing we can really do to simplify this anymore, so the exact area of the shaded segment is 48 pi minus 36√3.